Assalamu alaikum, dear respected students. We are to discuss about the structure and function relationship of monosaccharides today. So this lecture will cover the structure of monosaccharides, their physical properties, and also about their chemical properties. The structure we are showing over here is that of glucose. The function group in this case, as we have already discussed, is aldehyde, and the total number of carbon atom over here are 6, so it is an aldehyde source. If we talk about the numbering, so the function group carbon atom, which is carbonyl carbon atom, is all the times level is 1, so carbon number 1, 2, 3, 4, 5, and 6. So it is an aldehyde source. This is the open straight chain structure of glucose. Glucose is the most important physiological and biomedical monosaccharide, which we have discussed a bit in previous classes. It can be represented as a straight chain structure in the form of cyclic structure, or we can also call it a ring structure, and board and chair conformation. I have discussed about this structure, that is this carbon number 1, 2, 3, 4, 5, and 6. And to each and every carbon, the first one carbon is the functional group, bearing the functional group, that is CHO, that aldehyde functional group, and the farthest carbon, that is this one, the last one carbon, this carbon number 6, bears 2 hydrogen and 1 hydroxyl group. Rest of the carbon are hydroxylated, that is hydrogen and 1 hydroxyl group is attached. Before going into the detailed discussion of its projections, we will discuss about the hemiacetal and hemiketal formation. When an alcohol reacts with aldehyde, it results in the formation of hemiacetal. What is hemiacetal? Carbon atom bearing alkoxy group and hydroxyl group at a time. So we will call it a acetal carbon atom, and the substance is found to be the hemiacetal. While in case of ketones, the functional group is again carbonyl. So when it reacts, it forms the hemiketal. What is hemiketal? When OH and alkoxy groups are attached to the same carbon atom. If we have a look, so at least one carbon, this carbon bears hydrogen in case of hemiacetal, while in case of hemiketal there will be no hydrogen, and it is compulsory that the hemiketal carbon must bear the OH and OR group at a time. The Howard projection can be given as, that is, we have drawn the structure which is called pyranose. So the structure of glucose will be drawn on the pattern of pyranose ring structure. That is why glucose is termed as a glucopyranose. How can we draw it? We will take a start from the glucose form, the D-glucose. In this case, we shift the bond toward oxygen, and after shifting this bond, one of the hydrogen from the carbon number 5 will get attached to this oxygen, and the carbonyl carbon atom will get adhere through oxygen of carbon number 5. So as a result, we are getting the Pfizer projection, or sometimes we call it the Fischer projection. So this Pfizer projections can then be given the form of glucopyranose. That is, this is carbon number 1, 2, 3, 4, 5, and 6. So the numbering which we are going to draw over here will be in clockwise fashion. Then we move toward the Howard projection of or Howard formula of fructose. So first we will draw the open structure of fructose, which is a keto hexose. In this case, first we will shift the bond toward oxygen, where the carbonyl carbon atom is going to get a hydrogen. That is, there is a shift of proton from the carbon number 5 to the carbonyl oxygen, and then the carbon number 5 bearing the oxygen will get attached to the this hydrogen is shifted, so we are getting this OH group over here, and this same time this carbon will get attached to this one. Now you see that the structure over here is fructofuranoate, because the furan is a basic structure, and this structure resembles this one, so that is why we call it the furan nose ring structure, or we can call it the Howard projection formula of fructose. Now we see that there are some other conformation, that is chair and board conformation of D-glucose. So this structure number one is going to resemble a chair, so that is why we call it a chair conformation, and it can be shown while making its labeling from here: 1, 2, 3 and 4, 5 and 6. Now the second structure is going to represent a board, so that is why this is called a board conformation, and in the same fashion it can be labeled from here: 1, 2, 3, 4, 5 and 6. So these were some of the conformation which explains about the structures of monosaccharide. On the basis of these structures, we can explain the physical and chemical properties of monosaccharides, which we will do in the next video.